for the kinds of things that people need to do out in the world. And so I should mention that this notion of proxies, and then the next couple of slides I'm going to talk you through, all is ideas that recently, I hate doing this, but people tell me I'm show my book. So here I am showing my book. So, but I'm actually really excited about some of the ideas. So this is a book that just came out in January from O'Reilly. I co-authored it with Danielle Scher, who is a researcher at Microsoft Research. And, well, actually no, he's now unemployed, but he's getting ready to start a job with a startup company. Anyway, so the where we try to take the knowledge that we have as visualization designers and researchers and translate this aspect of how do you go from some sort of fuzzy question to something like what we've really tried to lay out in this book. So I have it if anyone's interested in looking at it. Okay, so let me talk you through an example, and then I'll explain a framework that's in the book for thinking about how we actually do this translation. So let's say that I have this task, this real-world task, just want to identify good film directors. Maybe I'm a film student, and I need to write a report about top film directors, and I want to use data to try to, base my assessment of who I want to write about in data. Okay, and so let's say that the data that I have is I go off to IMDb, and I'm going to scrape a bunch of information about movies. So now I have a data set that is about a whole bunch of movies and has lots of attributes about how much money they brought, how highly rated they are, and who directed them. So if I go back to my task, it turns out I can't actually directly answer this question with the data I have. I want to know about directors, but I really have information about movies. And so what I want to do is I want to identify proxies in that data set that I could use to be, that we write about, looks like this, where we take a task and we're going to identify these different components in a task in order to help us understand where we need proxies. So the first thing is that I want to understand the action, which is the thing you want to do. And then the objects, I want to identify those, which are the items that you want to take the action on. And then the measure, which is the value that you're actually interested in about those objects. So I want to know about directors. I want to know if they're good. I definitely don't have an attribute that says goodness. And so here, this is where I think things start to get really, really interesting often, which is these kinds of measures people care about. Often, rarely do you have that in your data set. And I think more interestingly is a good proxy is going to be pretty subjective based upon the person who's looking at the data and the things they care about. Maybe good means it brought in a lot of money. Maybe good means it has really high ratings. So in this case, let's just say that I'm going to select good movies or those that have high IMDb ratings. So by identifying these proxies, what I can do is translate this fuzzy task into something I can actually do with my data, which is identify movies with high IMDb ratings. That's something that I can actually design a tool to support me in doing. So that's about this idea behind proxies. But it turns out that these proxies are also imperfect. And so a lot of times we want to explore many proxies. Do we care about movies that have high ratings, but from just a few reviewers? Or do we care about movies that have pretty good ratings, but from many, many reviewers? So even this notion of my proxy here is something I need to explore more. So here's an example of if I look at the distribution of the number of raters, this is a number of raters versus the number of movies. I can see that most of the movies that have lots of raters is actually pretty low. And so if I explore that a little further, and I want to look at the scores that were given based upon the number of ratings, I can see that the ones that are given the most ratings that are good are down here at about 7, which isn't a super high rating, but it does indicate something about that there's popular movies and that there's movies that have fewer number of ratings. So we can use visualization as part of an exploratory data analysis step in order to help us better make sense of our proxies and validate them and refine goals of some projects that I've worked on. You can see I'm talking a million miles a minute, so I'll try to slow down. But what I want to talk about now is that a big part of this design is, in fact, identifying these good proxies and doing data counseling. But there is, of course, then this important step of also how do we design effective visualizations. And so this was the focus of a project that I worked on with a lab of biologists who study yeast. And their underlying scientific goals are to understand how genes and gene function evolve over time, which turns out has a lot of implications for our understanding of diseases like cancer and other diseases that are very diverse. So in order to address this goal, what this lab is doing is they're collecting data from a group of related yeast species about when and how much different genes are turned on and off during some window of time. And this notion of how much a gene is turned on or off is called gene expression. So in this regard, the lab is really interested in gene evolution, but the proxy that they're using to infer something about gene evolution is gene expression. It turns out that gene expression is just one of many different kinds of proxies that biologists use in order to study evolution, but it is the one that the lab uses. Because really, at the end of the day, the data that we collect about the world is just a proxy for the world. It is a partial and imperfect representation. And so this notion of proxy isn't just about supporting visualization, but I really think it's an inherent part of what we do as data scientists, and also just as scientists, anyone who's working with data, is to recognize that that data is just a proxy. So this lab was collecting gene expression measurements over time and in multiple species. And when I first began working with them, they were really struggling to make sense of that data using the standard techniques that biologists use, and I'll show you that in just a minute. But the tool that I ended up designing is shown here. It's called Pathline. And on this project, I had the opportunity to work with an amazing designer named Bang Wong, who specializes in scientific communication. So we worked together and we designed Pathline. And one of the big things we focused on in Pathline was to come up with some new and innovative ways to show gene expression compared to the ways that biologists typically look at it. And so I'll show you what we did. So traditionally, biologists use an encoding called a heat map. I'm guessing many people in here have probably seen an encoding like this before. You have some sort of like matrix layout, and you encode a value with color. So in this case, this is actually some data from the group. Genes are the different genes they're interested in are the columns. The rows are time points, and then the super rows are the 15 different species. And so what the lab told us when we were interviewing them is that they had a really hard time trying to make sense of fine-grained temporal patterns that they were interested in. Do these genes have high gene expression at a time shift away from each other? Are they mirror imaged? These sorts of things. This was really, really hard for them to make sense of in this view. And so Bang and I designed a new visual encoding that we call a curve map. And really what we did here is there's a guiding principle in the Viz community that spatial encoding is one of the most effective encoding channels you can use, whereas color actually is really hard for us to interpret. So using that, we came up with this design where, again, genes are columns, species are rows, and we're encoding those little time series as these charts. So to validate this new encoding, because of course you give this to scientists and they're like, well, I don't know, can you help me understand that this is a good way to look at this? One of the first things they looked at were 3 genes that they actually knew a lot about. Genes 5, 6, and 7. 5, 6, and 7, and then those are those 3 genes over there in the heat map. Okay, so what they knew about this triad of genes is that they knew that gene 5 behaved very differently across the species. It's a gene that evolved to do different things in these different species. And when you look down, you can see that these curves actually look quite different, which is in contrast to gene 7, which is a gene that actually performs the same function across all these species. So again, you can look down this column and you can see those gene expression measurements are very similar. So this confirmed things that they knew, but they did say it was a lot easier to be able to make these assessments using the curve map. Another thing they knew about was the pairwise relationship of 5 and 6. Now, these are 2 separate genes. There was a gene duplication event, and these are 2 separate genes, but that roughly do the same thing in these species, which is confirmed by the fact that as you go down, the pairwise relationship, the curves are quite similar. Again, something they knew and helped them to validate that this new visual encoding, they were able to see things they knew about and in fact be able to see it more easily. But then they actually saw something that they had never ever seen before. They'd been looking at this data for a number of years. And that was this pairwise relationship for species 7. So they looked at this and they were like, wow, that's really odd. How come for this one species that that gene isn't interacting in the same way? And they had no idea why this was. So this ended up causing them to go back and to design some follow-up experiments. And they actually discovered a previously unknown gene duplication event in the ancient history of the species. So this result was one of several that they ended up publishing while they were using this tool for analysis. And so what I liked about these case studies is that both of these, all these about their data, or all except for this last one. And so we were able to validate the new encoding. But this last one really, again, points to this idea that visualization often will show you the thing you're not expecting. And so I think reflecting on this, I think what's really interesting to me about a visualization designer is and then being able to think about, well, what is the role of the visualization? It was really a brainstorming tool. Might even argue it was creativity support. It was there to show them something that they weren't expecting that caused them to go back, using the knowledge that they have and to rethink some of their assumptions. They then designed new experiments and discovered something they hadn't seen before. And so I think this is really interesting because it sort of points to the idea that in many, many cases, visualization is really about a source of inspiration and brainstorming as part of a larger visualization design pipeline. This idea was really taken to the extreme in another project that I had working with some poets up at the U. In this problem, when I started working with these poets, they were really interested in just experimenting with how technology might affect what they do as poetry scholars. And they posed this question to me, which was, how might a visualization affect the aesthetic experience of a close reading of a poem? That's amazing. Took about 1.5 years to even begin to unpack what in the world this might have meant. Lucky for me, I had a really amazing grad student join my group, Nina McCurdy, who led this project, who has a extreme ability to be sensitive to our collaborators. What Nina was able to, Nina and I were able to learn is that neither of us knew a ton about poetry, but it turns out when poets write poems, poetic devices that people use in order to either build emotion, to play, these sorts of things in a poem. And so our collaborators were really interested in trying to visualize some of these devices in the context of a poem. It turns out that computationally detecting some of these things are open problems in computer science, like metaphor. Anyone who does NLP knows that this is a really hard problem. But there was one in particular that caught our eye as being very interesting to poets, but also computationally tractable. And this was their notion of rhyme. Now, when these poets say rhyme, it's not just the dog, hog kind of rhyme that at least I associate rhyme with. It was actually a much more rich and complex idea of sonic relationships in words. So rhyme from them is this very, very loose interpretation of patterns of sound. So what we did is we ended up developing an NLP backend to be able to detect a wide range of sonic patterns. And then what we do is we can detect sets of words in a poem that are related through these types of sonic patterns. So what we do then is we're able to then visualize these sets of sonically related words in the space of the poem. And we tried to capture the feeling of flow, which is something that our collaborators talk about a lot. And so the intersection and divergence of these different flows, these different sets, became the primary focus of the design that Nina came up with. So the tool she designed here is called Poemage. And what it does is it allows the poets to very freely go in and explore these different sets of rhyming words from different perspectives. So you can do it directly by looking at words in a poem. You can do it by looking at the sets of words that are based upon different types of rhyme patterns, and so on. So we developed this tool, and being good biz designers, we developed it and we deployed it out into our. One of the poets that we worked with used it to create something called erasure poems, which are a form of poetry that's generated by erasing words from existing poems to generate something that has perhaps new meaning. She used features of poemage to select and erase different sets of words, and she said she was guided by her own aesthetic sensibility. These are images of 2 erasure poems that she created for a gallery downtown, for a gallery display. In another case study, one of our poets used the tool to explore Gory Graham's poem, Reading Plato. And she described her approach to using the tool as sort of noodling around, where she would hover over different features in the tool and select and deselect things almost arbitrarily. She said that her greatest successes and insights came from just idle play and idle time with the tool. And she reflected on her experience in this. The interface felt engaging and responsive, and it reflects the sensibility that I experience when reading a poem. That interpretive readings are made choice by responsive choice, and that nothing is absolutely conclusive. So what I really love about this quote is that it emphasizes both the iterative nature of analysis and the interpretive process, but also it really emphasizes the lack of a perfect, precise answer in the data, this idea that we've sort of been talking about. And so while the nature of poetry scholarship is really to be interpretive and to brainstorm and be creative, I don't think it's necessarily all that different from the way that the scientists use the tools that I create for them as well. So in this case, it was, the poets would agree that this tool was really a creativity support tool for them. It was for brainstorming. But I think it's interesting to think about that in the context of more objective types of situations that we also design for. And one of the things that was interesting is that we sort of posed the question to ourselves, which was, if they could just play around and idly select things, they weren't really analyzing the data that we created for them. What if we just given them randomly grouped sets of words? Would that have been just as productive for them? I don't know, but I think this notion of rethinking the role that visualization plays in analysis leads to some interesting brainstorming about what might we be designing for at all. And so when we design tools for experts, we assume that it's important to give people visualizations that are going to be as accurate and readable as possible. And yet it's not clear that that's necessarily the role that visualization plays in the discovery process. And I think the other thing that's important to note here is that this idea that we want to create really effective, accurate visualizations assumes that the data itself that we're looking at is a very accurate, precise representation of the world. Which gets to one other project that I wanted to talk to you guys about, which is a project where we worked with global health experts at USAID, or I should say some government organization that works with global health. And we worked with people that were looking at the Zika virus and trying to understand how it was traveling and how to parcel out international aid programs to try to curb the spread of Zika, and of course all the related health implications like microcephaly. So this was another project that my student Nina headed up, and we began with a 6-month field study where she went to USAID and embedded herself within the Zika team for 6 months. This project at the start had all the makings of a classic design, visualization design project. The team had data, or at least they roughly knew where to get it. They'd already been playing around with visualizations and finding them challenging to use. And most importantly for us as researchers, they were really excited about working with us to come up with some new visualization designs, and were willing to give us a lot of their time. So during this field study, Nina developed and deployed a prototype tool to explore their the Zika outbreak data, along with data about the in-country programs that organizations were running. So the goal of the tool was to help these experts make decisions about whether or not to move or expand various programs as they projected or inferred what they thought the outbreak was going to do. We evaluated this tool with a wide variety of stakeholders, and the feedback indicated that the design was in fact a very effective representation of the data. So yay, great, we designed something for the data that seemed to work well. And yet, we noticed a complete hesitation from our collaborators to actually adopt and use this tool. And so we were really, the tool was a good representation of the data, the Zika outbreak on the ground. So, so this came up in a number of discussions. One of the first ones where we noticed it was when Nina was showing some of these experts a chorus of number of infected cases in some countries. And here Brazil shown in dark red and Colombia showed in lighter red, indicating that Brazil had a higher percentage of confirmed cases. And one of the collaborators remarked, well, that's actually, unfortunately, leads to these problems, and we came to discover that it's of their knowledge and on the fly sort of mentally changing what they saw based upon what they knew. As one of our collaborators sort of candidly put it, she said that using or testing the visualization tool with us required suspending disbelief around the quality, consistency, and availability of data. And so this really led us again to rethink, well, what is the role of visualization here? And we decided to instead focus on mechanisms to support these experts in trying to, and what I think is really interesting in this is that, we came up with all of this in the context of a very specific problem, Zika, public health Zika data. And yet, if you think about a lot of the data that we use and generate both personally as well as professionally comes from similar kinds of heterogeneous distributed pipelines. I know this is certainly the case in biology, where now, any biologist who has an NIH grant is required to release their data, and yet the nuances of experimental design isn't always completely clear in the data set or in the documentation around it. I also have projects about air quality and low-cost sensors, and air quality around the world is really being transformed by the ability for people to just put out these new low-cost sensors all over the place and combine them with EPA-grade sensors. And yet, when we put these things together, there's a lot that my air quality collaborators know about, well, this sensor uses this measurement mechanism, and so I know you have to sort of calibrate it in this way, and so they do all this in their head. And so I really think this idea of expert knowledge of these implicit errors is really prevalent, and yet how do we go about trying to capture that and then using it as part of data analysis? Anyway, so that's one of the things I was really interested in this project. And so I think we also do this even when we think about visualizations for the general public. If you think a lot about maybe visualizations of midterm election data and things like that, I think, but when we talk about how we interpret that, we call it bias as opposed to expert knowledge. But anyway, so I think, my sort of, also because it turns out there's people in the world who tend to have a lot of knowledge about that. And that visualization is really, quite often it's about supporting the interpretation and validation and refinement of proxies. It's a thinking tool that helps us understand, do these proxies make sense? Do I need to look at something else? But at the end of the day, the insights that we get from data come from our own knowledge and experience, and not specific answers that we find in the data. That data and hence visualizations perhaps are a way to help us be creative and to inspire us to come up with those insights. And so then what I think is interesting is then thinking about, well, if you take that sort of perspective, what does that mean for visualization design? I think it means two things. I think the first one is that the idea of getting to insight is something that happens through exploration and through think about ways to more accurately capture that exploration process. And I think a lot of the emergence of digital notebooks like Jupyter and Observable are a step in that direction. And I think second, there's this interesting question of, well, if we're not using visualizations to find the accurate answer, what might that change about the way that we design visualizations? What might that change about where we put our time and energy? Is it to build an NLP backend or just give them random sets of words? I don't know. I don't really have answers to these questions, but these are things that I'm definitely pitching at as many people as possible to see, just to have a dialogue, because I think it would be very interesting. And that's where I'm going to end that. So thanks for letting me talk a mile a minute about some of these things I'm really excited about.
Anybody have questions?